Now let's look at developing the ordinary least squares estimates for B sub 0 and B sub 1 using this numerical example. This is from your textbook. The x values and the corresponding y values are given. So first thing to do usually when you have a simple regression problem is to plot the x and y values. Okay, so go like that. And we will do a scatter plot. Okay. Now if x is the first column and y is the second column, we can highlight both columns and then simply select scatter plot. But if it is the other way around, if y is the first column and the x is the second column, then you have to insert y first. Don't highlight both the columns. Insert y first and then go into select data, edit, and add your x values. Okay. But if x is first and y is second, you can highlight this way, and the x and y, the y label will be used as a series name, and then the numerical values of x will be the x range, the numerical values of y will be the y range, and that will be automatic. Okay, so let's put the scatter plot right there. Now you can see there is a kind of a relationship between x and y. Okay, so this is scatter plot. So okay, now what is that b sub 0 and b sub 1 values that we can get using the ordinary least squares formulas? And for that we're going to use this format of the formula. So we need x times y, and then sum of x, sum of y, and sum of x squared. Okay, and so that will be x times y. Okay, then we need x squared. Okay, now while we are at it, let's do y squared also. We will need that for computing what are called sums of squares. So let's set that up as well. So now copy those values. We'll put the border back, and then we can sum these numbers. So you get sum of x, right? And then sum of y, sum of xy, sum of x squared, sum of y squared. Okay, let's assemble those here. Now sample size, okay, let's get that using count of x's, which will be the same as the count of y's. Sum of x is that. Sum of y is that. Sum of xy is that. Sum of x squared. And then finally sum of y squared. So these are the summary values. Now average, so let's find the average of x bar, average of x bar, okay, and then average of y, which is y bar. Okay, so these are the numbers that we need to calculate b sub 0 and b sub 1. So this is our b sub 1 formula. It kind of looks complicated, so let's split this up into two parts. The numerator, so the numerator for b sub 1 is sum of x times y, so which is that, okay, minus sum of x times sum of y, so sum of x times sum of y divided by sample size n. So that's the numerator, and the denominator is sum of x squared minus sum of x squared, okay, divided by sample size. So now if you divide the numerator by the denominator, we'll get the slope value. Now intercept is y bar, okay, minus b sub 1 times x bar. Okay. So now we have b sub 0 and b sub 1. Now we can get the values of b sub 0 and b sub 1 using Excel functions as well. So there is an Excel function called intercept. Okay, and intercept requires we identify the y range first and then the x range. Okay, like that. Okay, y range and then the x range. So that gives you the y-intercepts exactly the same value like there. And then slope, again y range first and then the x range. Okay, and here is the estimated y hat equation. So 4.36, the b sub 0 value, plus b sub 1 times x. So this is the ordinary least squares estimated line for y.